Hello all, my name is Shalom Satvik Tatapudi and I belong to group 9 in the subject KDD. So this is part of our project presentation and these are my 5 slides that gives the detail about measures of cluster validity. So there are numerical measures that are applied to judge various aspects of cluster validity and they are classified into the following types. So as you can see in the slides, there are two types of measures. One is internal measure. In internal measure, we use to measure the goodness of a clustering structure without respect to external information. The examples are, the sum of squared error method and cohesion and separation and Silhouette quotient. And the other method of measure that we use for cluster validity is actional measures. There are several measures like entropy, purity, precision, which are commonly used to evaluate the performance of classification model. But in these slides, I'll be discussing about entropy and purity. Let's move to the next slide. Here we have the SSE. In SSE, the clusters in more complicated figures are not well separated, and the internal index used to measure the goodness of a clustering structure without respect to the external information. SSE is very good comparing in two clusterings or two clusters, um, and it can also be used to estimate the number of clusters. And let's move to the next slide, which is cohesion and separation. So cluster cohesion measures how closely the data or the related are objects in a cluster, and cluster separation measure how distinct or well separated a cluster is from other clusters. So example is the squared error. So cohesion is measured by within cluster with sum of squares, as you can see the formula, and separation is measured by between the sum of squares. You can see the formula where Ci is size of cluster I. And a proximity graph based approach can also be used for cohesion and separation. Cluster cohesion is sum of the weight of all links within a cluster. Cluster separation is sum of weights between the nodes in the cluster and nodes outside the cluster. Let's move to the other measure that we have is Silhouette quotient. Silhouette quotient combine ideas of both cohesion and separation, but for individual points as well as clusters and clusterings. For an individual point I, for example, you can see the figure that is given. Calculate A, this average distance of I to the points in its cluster, and calculate B is equal to the min of average distance of I to point in other cluster. The Silhouette quotient for a point is given by S is equal to 1 minus A by B if A is less than B. So typically between 0 and 1, the closer to 1, the better. So it can be calculated by average Silhouette with width for a cluster or a clustering. And next move to the actional measures of cluster validity. So here we have a k-means clustering results for LA document set. And so the entropy is for each cluster the class distribution of a data is calculated first. For cluster J, we compute Pij, the probability, and the member of cluster J belongs to class I as follows. And the purity is defined using the terminology derived for entropy. The purity of cluster J is given by purity is equal to max Pij, and the overall purity of a clustering by purity, and the formula is given. So final comment I would give of the cluster validity is the validation of clustering structures is the most difficult and frustrating part of cluster analysis. Without a strong effort in this direction, cluster analysis will remain a back art, accessible only to the true believers who have experience and get courage. Well, thank you for giving this time, and